So here is our third lecture, which is equilibrium of concurrent forces. That means here we'll learn about the state of equilibrium and deal with the forces, concurrent forces, which are in equilibrium state. So basically here we are going to implement our concepts of equilibrium. We had already learned that in order to be in equilibrium state, each and every component or each and every force system should present or should satisfy some criteria, which are like summation of f of x equal to 0, summation of f of y equal to 0, and summation of f of z equal to 0 for 3D cases. For 2D, we just need to consider these first two. So here we are going to implement these two criteria and determine our forces. So let's see how we will be able to deal with equilibrium of concurrent forces. In our first example, we are asked to determine the surface reactions of the cylindrical drum which weighs 100 Newton. That means the self-weight of the drum, which is example 1. Here the self-weight of the drum is 100 Newton. We can see here the drum has been placed right at the corner of a wall. So this wall is exerting a force upon this drum, which is basically nullifying the force of 50 Newton which is acting on this drum. So from the question we can say that this drum will be having a unit weight or self-weight. This drum will be having a self-weight of 100 Newton. We know that self-weight acts directly downward, that means perpendicular in downward direction. So this is 100 Newton. As the drum is being placed right at the corner of a wall, so it will have a contact surface with this wall. This contact surface is this one and this one, and we know that a force used to arise or reaction force will arise right at the point of contact surface. So here is the contact surface. Due to this contact surface, this wall will be exerting a reaction upon this drum, and this contact surface, through this contact surface also a reaction will be imposed on this drum, and this whole thing will keep the drum in an equilibrium state. And the major rule, or the first and foremost rule to deal with this type of problem, is that where you will see the contact surface, a force or a reaction force will arise in this contact surface just perpendicular to this contact surface. So here we can see the contact surface, a reaction force will arise perpendicular to this contact surface. Here we can see another contact surface, so, or contact plane, whichever we may say. So a reaction force will also arise in this contact surface. So in total we can see 1, 2, 3 and 4 50 Newton is acting upon this drum. So now we need to draw a free body diagram. A free body diagram is a diagram which represents just the reaction forces and the forces acting on a body. So here is our drum, and in this diagram, which is exactly the free body diagram of this problem number 1, all the forces and reaction forces has been represented in this figure. So this is actually the free body diagram. Shortly it is said as FBD. Now in this free body diagram we can see the reaction R2 due to this contact surface and reaction R1 due to this contact surface, which are acting perpendicular to the body. We know that the reaction forces acts perpendicular to the contact surface, so we have denoted in that manner. And here is our inclined force of 50 Newton which is acting on this body, and we can see that this 50 Newton is 30 degree at a 30 degree angle with the horizontal axis. That means the angle is 30 degree. So as this is an inclined force, and we know that each and every forces will be having two components, and this inclined force will also have two components, but as we can see, this R1 and R2 coincides with the axis or the major axis, which is x and y. That means R2 is directly acting through the x-axis, it is coinciding with the x-axis, so there will be no component of this force, y component of this R2 force. And similarly, this R1 force is R1 reaction is coinciding with the y-axis, so it will also not having any force component or components in x direction. Same case for 100 Newton. This 100 Newton self weight is acting downward and coinciding with the y-axis, so it will also not have any component in x direction. But as this is 15, this 50 Newton is an inclined one, it will be having two force components. One is in x direction and one is in y direction. So denoting these two components of 50 Newton, we know that 50 Newton is at an angle of 30 degree with horizontal one, so this horizontal component will be 50 cos 30 degree, and this vertical component will be 50 sin 30 degree. So here we have already denoted all the forces, so we can easily eliminate this 50 Newton. So now we can see all these forces are acting through a single point, which is the center. So this is actually representing a concurrent force system, and as it is mentioned that we are dealing with equilibrium of concurrent forces, so here we will be applying summation of f of x equal to 0 and summation of f of y equal to 0 in order to determine action force R2 and R1, which has been asked in our question. This surface reaction, we are asked to determine the surface reactions. That means we need to determine R2 and R1. So let's see how we can determine these two reaction forces. So firstly, we are going to implement our first condition, which is summation of f of x equal to 0. So applying summation of f of x equal to 0, here we can see summation of f of x equal to 0, and we know that x force acting rightward, that means while considering the global coordinate, x is positive rightward, x is negative leftward, x is y is positive upward, and y is negative downward. So the forces acting on rightward will be positive, and forces acting on leftward will be negative. Forces acting on upward will be positive, forces acting on downward will be negative. Here we can see all the forces in this free body diagram. So now considering for x directional forces, summation of f of x equal to 0, and we have considered right side as positive. Now we can see the x directional forces in this figure. First one is R2. R2 is acting rightward, so here is positive R2, and we can see here 50 cos 30, which is acting leftward, so it will be negative 50 cos 30. So negative 50 cos 30. We cannot see any other forces, x directional forces, in this diagram. So we can conclude here for f of x equal to 0. We can see that R2 minus 50 cos 30 equal to 0. That means from here we will get the value of R2, 43.3 Newton. Just changing the side of 50 cos 30. Now for summation of f of y is equals to 0, we need to consider all the y directional forces. Here we can see the first y directional force R1, which is acting upward, so plus R1. 100 y directional force is acting downward, so minus 100. 50 sin 30 is acting downward, so it will be minus 50 sin 30. So from here we will also get the value of R1. So in this way we will get the value of R2 and R1, which are exactly the reaction forces that we have asked in our question to determine.